Good morning students. Today we start next topic of P block element group 15 elements. Next we already start this chemical properties of group 15 element. Today we discuss second property, reactivity towards oxygen, formation of oxides. So nitrogen have tendency to form p-pi multiple bond between nitrogen and oxygen atom, but the other group 15 elements form only +3 and plus oxidation state with the oxygen, because they form only trioxide or a pentoxide with oxygen. But nitrogen have tendency due to small size and have tendency to form p-pi multiple bond, because the energy level of 2p orbital of nitrogen and 2p orbital of oxygen atom will be same. That's why they are easily overlap, because both element atoms have same orbital, that is 2p orbital, which have same energy. That's why they have tendency to form p-pi multiple bonds. So let us discuss how many oxides formed by group 15 elements. So this is the oxidation state: nitrogen, phosphorus, arsenic, antimony and bismuth. So nitrogen show all the positive oxidation state with oxygen. First one is nitrogen oxide, N2O, which is also called laughing gas, nitric oxide, nitrogen trioxide, nitrogen tetroxide, nitrogen pentoxide. But phosphorus does not show +1 or +2 oxidation state. No other group element show +1 or +2 oxidation state with oxygen. But phosphorus form P4O6, it's a dimer, and P4O8, P4O10. So +3, +4, +5 oxidation state with oxygen. Next, arsenic also show +3 and +5 oxidation state with oxygen. Antimony also show +3 and +5 oxidation. Bismuth show only +3 oxidation state, but it does not show +5 oxidation state. We already discussed in our previous video, due to inert pair effect. Due to inert pair effect, bismuth show only +3 oxidation state. So the oxides are of non-metals are acidic nature. You already know metal hydroxides are amphoteric in nature and metal oxides are basic nature. It means the oxides of nitrogens are acidic nature, and the acidic character decreases from nitrogen to bismuth. So it means nitrogen or phosphorus oxides are acidic in nature, arsenic, antimony are amphoteric, and bismuth oxide is basic in nature. So let us discuss why they are basic in nature. More the electronegativity of element, more acidic is its oxide. जिन्नी electronegativity किस group 15 ਦੇ element ਦੀ ਜਿਹਦੀ ਜ਼ਿਆਦਾ ਹੋगी, so already you know कि nitrogen ਦੀ ਜਿਹੜੀ oxidation state ਉਹ ਜ਼ਿਆਦਾ ਹੈ, so ਇਸ ਕਰਕੇ ਜਿਹੜਾ ਉਹਦੇ oxides ਨੇ ਉਹ ਜ਼ਿਆਦਾ acidic ਹੋਣਗੇ. Second point, in higher oxidation state oxide is more acidic strength. So out of these 5 oxides of nitrogen, N2O5 is more acidic nature as compared to other oxides. So also in case of phosphorus, P4O10 is more acidic as compared to P4O6 and P4O8, because in this oxide its oxidation state is +5. Similarly, in case of arsenic, this is more oxide out of these two. Antimony, this oxide is more acidic as compared to this oxide. But acidic character when we move from nitrogen to bismuth, that decreases. So in which the element atom higher in oxidation state, stronger will be the acidic nature of that oxide. So there is an increasing order of acidic nature of the oxides of nitrogen, because +1 to +5. So higher oxidation state of atom is oxide is more acidic as compared to lower oxidation. First two oxides of nitrogen is neutral in nature, but other are acidic character increases when we move from +1 to +5 oxidation state. And when we compare +3 oxidation state oxide of all the group elements, so nitrogen oxide is trioxide is more acidic as compared to other group members. So it's a decreasing order of acidic character of nitrogen in +3 oxidation state oxides. So similarly in case of pentaoxides, so nitrogen pentoxide is more acidic as compared to phosphorus, as compared to arsenic, as compared to antimony, because bismuth does not show +5 oxidation state. So these are the oxides of group 15 element. Next we discuss the reactivity of group 15 element with halogens, formation of halide. So group 15 elements react to form two series of halide, EX3, EX5. What is E? E represent to the group 15 element nitrogen, phosphorus, arsenic, antimony or bismuth. So nitrogen does not form pentahalides due to absence of d orbital. It does not form NX5. Why? Because there is a non-availability of d orbital. Okay, it extends its covalence only up to 4 bond, not up to 5 bond. So due to absence of d orbital, nitrogen does not form a pentahalide. NCl5, NF5, Ni5, NBr5. So pentahalides are more covalent than trihalides. Okay, ਜਿਵੇਂ ਜਿਵੇਂ ਸਾਡੇ ਕੋਲ ਸਾਈਜ਼ ਇਨਕਰੀਜ਼ ਕਰਦਾ, ਮੋਰ ਨੰਬਰ ਆਫ ਐਟਮਸ ਸਾਡੇ ਕੋਲ ਅਟੈਚ ਹੁੰਦੇ ਨੇ ਗਰੁੱਪ 15 ਐਲੀਮੈਂਟਸ ਨਾਲ, ਜਿਹਦੇ ਕਰਕੇ ਆਇਨਿਕ ਕਰੈਕਟਰ ਡੋਮੀਨੇਟ ਕਰਦਾ ਓਵਰ ਕੋਵਲੈਂਟ ਕਰੈਕਟਰ. ਸੋ ਕੋਵਲੈਂਟ ਜਿਵੇਂ ਜਿਵੇਂ ਆਕਸੀਡੇਸ਼ਨ ਸਟੇਟ ਇਨਕਰੀਜ਼ ਹੁੰਦੀ ਜਾਂਦੀ, ਉਵੇਂ ਉਵੇਂ ਕੋਵਲੈਂਟ ਕਰੈਕਟਰ ਜਿਹੜਾ ਇਨਕਰੀਜ਼ ਹੁੰਦਾ ਜਾਂਦਾ ਓਵਰ ਦੀ ਆਇਨਿਕ ਬੌਂਡ. ਸੋ ਟਰਾਈਹਲਾਈਡਸ ਜਿਹੜੇ ਹੈਗੇ ਉਹ ਕਿਤੇ ਨਾ ਕਿਤੇ ਆਇਨਿਕ ਨੇਚਰ ਹੁੰਦੇ, ਸਪੈਸ਼ਲੀ ਫੁਲਰਾਈਡਸ. ਜੇ ਅਸੀਂ ਫੁਲਰਾਈਡਸ ਦੀ ਗੱਲ ਕਰੀਏ, ਸੋ ਐਕਸ ਇੱਥੇ ਕੀ ਹੈ, ਹੈਲੋਜਨਸ ਨੇ, ਫਲੋਰੀਨ, ਕਲੋਰੀਨ, ਬ੍ਰੋਮਾਈਨ, ਆਇਓਡੀਨ. ਸੋ ਫਲੋਰੀਨ ਦੇ ਜਿਹੜੇ ਟਰਾਈਹਲਾਈਡਸ ਨੇ ਉਹ ਸਾਡੇ ਕੋਲੇ ਮੋਸਟਲੀ ਕੀ ਹੁੰਦੇ ਨੇ, ਆਇਨਿਕ ਨੇਚਰ ਹੁੰਦੇ, ਡਿਊ ਟੂ ਮੈਕਸਿਮਮ ਇਲੈਕਟ੍ਰੋਨੈਗੇਟਿਵਿਟੀ ਡਿਫਰੈਂਸ ਬਿਟਵੀਨ ਗਰੁੱਪ 15 ਐਲੀਮੈਂਟ ਐਂਡ fluorine. So all trihalides of group 15 elements are stable except NX3. Nitrogen ਦੇ ਜਿਹੜੇ trihalides ਨੇ ਉਹ stable ਨਹੀਂ ਹੁੰਦੇ, only NF3 is stable. NCl3 is explosive in nature, NBr3 and Ni3 are very unstable and not easily available. So ਇਸ ਕਰਕੇ ਸਾਡੇ ਕੋਲ ਜਿਹੜੇ ਬਾਕੀ trihalides ਨੇ, ਫਾਸਫੋਰਸ ਦੇ, ਅਰਸੈਨਿਕ ਦੇ, ਐਂਟੀਮਨੀ ਦੇ, ਬਿਸਮਥ ਦੇ, they are more stable than nitrogen trihalides. So NF3 is the only trihalide from nitrogen halides that is stable. NCl3 is explosive in nature, so NBr3 and Ni3 is not stable, very unstable in nature. So next we discuss the geometry of a trihalide in EX3. These are the trihalides of group 15, have pyramidal shape. Why? Due to presence of lone pair. So its hybridization is sp3. There are 2 electron in s orbital and 3 electron in p orbital. Half filled configuration है साढ़े को. So if we discuss the halides of phosphorus, px3, x may be a fluorine, chlorine, bromine और iodine. So इट शो अ पिरामिडल शेप, क्योंकि 2 एस ऑर्बिटल च इलैक्ट्रॉन ने, 3 साढ़े को पी ऑर्बिटल्स ने. सो 3 इलैक्ट्रॉन्स, 1 इलैक्ट्रॉन शेयर बाय ईच हैलोजन विद दी फॉस्फोरस 1 पी ऑर्बिटल इलैक्ट्रॉन. सो शेयरिंग होंगी है जिहदे करके साढ़े को 3 जिहड़े शेयर्ड पेयर ऑफ इलैक्ट्रॉन्स ने ते एक लोन पेयर अवेलेबल है जिहड़ा कि साढ़े को इस वे दे नाल अरेंज हुंदा. सो ड्यू टू प्रेजेंस ऑफ लोन पेयर इट शो अ पिरामिडल ज्योमेट्री और पिरामिडल शेप. So if we discuss the geometry of pentahalide, EX5 have trigonal bipyramidal geometry. Its hybridization is sp3d. So here promotion of electron from 3s orbital to 3d, क्योंकि साढ़े को नाइट्रोजन तो शो नहीं करती हैगी pentahalides because due to absence of d orbital. ठीक है. So in case of pentahalides, so nitrogen does not form pentahalide due to absence of d orbital. So 3s so एक electron promote होके d orbital चले जाता, because there is availability of d orbital in case of phosphorus, arsenic or antimony. So 3d orbital available in case of phosphorus. So इस case ਦੇ ਵਿੱਚ 5 ਸਾਡੇ ਕੋਲ halides ਨੇ ਜਿਹੜੇ ਕਿ ਇੱਕ ਇਲੈਕਟ੍ਰੋਨ ਸ਼ੇਅਰ ਕਰਦੇ ਨੇ, 1 from s orbital, 3 from 3 and 1 from d orbital. So the hybridization is sp3d. So according to this hybridization, its shape is trigonal bipyramidal. Trigonal bipyramidal. So these are the 3 equatorial bonds ਜਿਹੜੇ ਆ ਸਾਡੇ ਕੋਲ trigonal planar ਚ ਨੇ. These are called equatorial bond, and these 2 are perpendicular. These are called axial. So they are called axial bond. So these are called equatorial. Equatorial bond. ਸੋ ਇਹ ਸਾਡੇ ਕੋਲ ਇਕੁਆਟੋਰੀਅਲ ਨੇ, ਇਹ ਸਾਡੇ ਕੋਲ ਕੀ ਹੈ, ਐਕਸੀਅਲ ਬੌਂਡ ਨੇ. ਤੇ ਇਕੁਆਟੋਰੀਅਲ ਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ ਬੌਂਡ ਹੈ ਉਹ 120 ਡਿਗਰੀ ਦਾ ਹੁੰਦਾ, ਤੇ ਇਹ ਸਾਡੇ ਕੋਲ 90 ਡਿਗਰੀ ਦਾ. ਤੇ ਜਿਹੜੀ ਬੌਂਡ ਲੈਂਥ ਹੈ ਸਾਡੇ ਕੋਲ ਇਕੁਆਟੋਰੀਅਲ ਬੌਂਡ ਦੀ ਘੱਟ ਹੁੰਦੀ ਹੈ ਐਸ ਕੰਪੇਅਰ ਟੂ ਐਕਸੀਅਲ ਬੌਂਡ, ਬਿਕੋਜ਼ these 2 perpendiculars are 90 degree to each equatorial bond, ਜਿਹਦੇ ਕਰਕੇ they feel a maximum repulsion. That's why the bond length increase of axial bonds. So that's why the all bond lengths are not equal in case of PCl5 due to repulsion between the axial bond and equatorial bond, because they are perpendicular to the equatorial bond. So that's why the all bond lengths not are equal in PCl5. This question is very much important. So all the pentahalide act as a Lewis acid due to availability of d orbital. So जिन्ने भी साढ़े को pentahalides ने they act as a Lewis acid. Why they act as a Lewis acid? Because they ड्यू टू अवेलेबिलिटी ऑफ वेकेंट डी ऑर्बिटल, क्योंकि खाली ऑर्बिटल अवेलेबल ने जिहदे च साडे को ईजिली एक्सैप्ट कर सकते हैं इलैक्ट्रॉन पेयर टू एक्सटेंड देयर कोआर्डिनेशन नंबर। सो किसी भी हलाइड तो नैगेटिवली चार्ज एटम तो आयन तो साडे कोले इलैक्ट्रॉन्स आ जिहड़े वो ऑक्यूपाई लै सकते हैं। सो इस करके दे एक्ट एज अ लुईस एसिड। सो MX5 when react with halide any one of them it form MX6 जानी अपना कोऑर्डिनेशन नंबर 5 तो की कर लिया 6 ਦੇ ਵਿੱਚ चेंज कर लिया। क्लियर। So PCl5 is covalent in vapor state and but exist in a PCl4 positive, PCl6 negative in crystalline form, means ionic nature ਦੇ ਵਿੱਚ exist करता है ना crystalline form। So PCl4 ਦੀ geometry tetrahedral ਹੁੰਦੀ ਹੈ ਤੇ PCl6 ਦੀ octahedral ਹੁੰਦੀ है। Next we discuss the reactivity towards metal. Group 15 elements react with metals to form their binary compounds exhibiting a -3 oxidation state. So calcium nitride, calcium phosphide, sodium arsenide, zinc strip, antimonide, magnesium bismuthide. So if you have any doubt up to this topic, up to reactivity of chemical properties of group 15 element, you can call me or through message you clarify your doubt. Thank you.